Okay, so problem one is a motorist drives south at 20 meters per second for 3 minutes, then turns west and travels at 25 meters per second for 2 minutes, and finally travels northwest at 30 meters per second for 1 minute. For this 6-minute trip, find the total vector displacement, the average speed, and the average velocity. Let the positive x-axis point east. So we have southwest and northwest. So yeah, this is problem number one, chapter two, on chapter four. All right, so we have a motorist that drives south for 20 meters per second for 3 minutes, which is actually 180 seconds. So that's going to be 3,600. So this. Okay, so we'll call that 3,600 meters. Okay, then west at 25 meters per second for two minutes, which is 120, which is going to be 30, 300, 3,000, 3,000, 3,000 meters. Okay, and then northwest at 30 meters per second for 60 seconds, which is 1,800 meters. So it's going to be roughly something like that. Okay, so we want to find the total vector displacement for A. So we want to find that. All right, so we need to see what this position is. So we're going to get we're going to need to find what this distance is here and what that distance is here and add them to these guys. Well, with this being a 45-degree angle at northwest, this horizontal distance is going to be 1,800 cosine 45, and this is going to be 1,800 sine 45. Okay, so our total distances are going to be negative 3,000 meters plus 1,800 cosine 45 I hat plus negative 3,600 meters plus 1,800 sine 45, and that's running off the page here. Sine 45 j hat. Okay, so then we have to go figure those things out, and that just gets kind of messy. But 1,800 cosine 45 is 1,800 divided by 2 squared. Okay, this value actually for both of these guys is going to equal 1,273 meters. So our I hat direction is going to wind up being 1,273 minus 3,000, which is a negative 1,727 meters. I hat. And then it's another 600 meters more than that j hat. Okay, so a negative 2327 j hat. Okay, that would be the total vector displacement. If you wanted to find out the magnitude and direction of this, you do the Pythagorean theorem. Um, Pythagorean theorem, and then you do the arc sine of the j hat over the I hat. So it would be, so it'd be so it'd be the r vector distance, and then it would be negative 2327 over 1727 inverse tangent of all that right there. So that's A. Okay, B. Okay, we're looking for the average speed. Well, for the average speed, we're going to need to find, the average speed is the total distance traveled divided by the time. So that's just going to be our 3600 times 3000, or plus 3000 plus the 1800. So that's 3600 plus 3000 plus 1800 gives us 6600 plus 1800 equals 84. All that divided by 6 minutes is equals 1200 meters per minute. And if we divide that by 60 again, we're going to get 20 meters per second. So our average speed is going to equal 20 meters per second along that trip. Our average velocity, however, is different. And so that's going to be, we're going to take our other vector, and we take the magnitude of that. So we're going to have to do that. So that's the negative 1727 squared plus 2327 squared. Square root of all that. 727 squared plus 2327 squared equals, square root of that equals about 2900 meters. And we did that in a total of 120 seconds. No, 360 seconds. That winds up being that comes out to 8.1 meters per second, and that arctan will do that just for the heck of it. So that's 2327 divided by 17.7, and that's going to be right. So that's going to be at 53 degrees south of west. Object not drawn to scale. Okay, so that would be number 1.